Hello everyone. In this video, we talk about the expected value of a function of discrete random variable. Often, we are interested in the expected value of a particular function h of x rather than x itself. Let's take a look at the following example. We have a PMF for x. X can take on value -1, 2, 3, and 5, with probabilities 0.25, 0.1, 0.35, and 0.3 respectively. We would like to compute the expected value of 3x. So here, the function h of x equals 3x. And now we introduce a new random variable, say y, where y equals 3 times x. From that, we can construct a new PMF table involving the random variable y. For every possible value of x, we get the corresponding value of y, where y equals 3 times x. So here, when x equals -1, y equals -3. When x equals 2, y equals 6. When x equals 3, y equals 9. When x equals 5, y equals 15. The probability don't change. And therefore, we have a new PMF table, the table for the random variable y. To compute the expected value of 3x, this is equivalent in computing the expected value of y with the new PMF table. We sum up all possible value of y for the expression y times py, and we get the first term, -3 times 0.25, plus the second term, we have 6 times 0.1, and the next term, 9 times 0.35, and the last term, we get 15 times 0.3. Upon calculation, we get the expected value of y equals 7.5, and this is also the value for the expected value of 3x. Instead of computing the PMF of a new random variable, the expected value of any function h of x can be computed by the following expression. The expected value of h of x equals h of x1 times p of x1 plus h of x2 times p of x2, and then all the way for all possible values of x. So we have the expression, the expected value of h of x equals the summation of all possible values of x on the expression hx times px. You can compare this expression with the expression of e of x. Here we replace the x by h of x, and then e of x is replaced by e of hx. The probability px doesn't change. Let's revisit the example. Compute the expected value of 3x. Here we have the expected value of 3x, h of x equals 3x. Applying the expected value of h of x formula, the first term we have 3 times -1 and then times 0.25. The value 3 here is just the coefficient of h of x, the 3 in the 3x, and then multiply the first value of x, in this case, x equals -1. So we get 3 times -1. And then multiply by the corresponding probability 0.25, and then we get the first term. And then the second term, we have 3x, where x equals 2, so we have 3 times 2, and then multiply the corresponding p of x, which is 0.1. The next term we get 3 times 3 times 0.35. And the last term, we get 3 times 5 times 0.3. Upon calculation, we should get the same value, 7.5. Let's compute another expression, the expected value of x squared plus 1. Similar procedure. We have h of x equals x squared plus 1. And then applying the expectation of h of x formula. So we will multiply x squared plus 1 with the associated probability for each possible value of x. So the first term, we have x equals minus 1. So we have minus 1 squared plus 1 multiplied by the probability 0.25. And then the second term corresponds to x equals 2. We get 2 squared plus 1 multiplied by the probability 0.1. The next term, x equals 3. We get 3 squared plus 1 times 0.35. And the last term, x equals 5. We get 5 squared plus 1 times 0.3. Upon calculation, we get the expected value of x squared plus 1 equals 12.3. We have a special case when h of x is linear. That is, h of x equals ax plus b for any constants of a and b. So let's see how we can simplify the expression in computing the expected value of h of x. So here we have the definition. And now h of x equals ax plus b. So we replace h of x by ax plus b. Expand this, we get the summation of ax times px plus the summation of b times px. Next, since a and b are constant, so we can factor them out. And the next step, here we get a times the summation of x times px plus b times the summation of p of x. So what is the expression for the summation of x times px? By definition, this is the expected value of x. And then the summation of p of x, summation all over possible value of x, then this must equal 1. This is the property of any PMF. So here we get a times the expected value of x plus b times 1. So we get the expression. The expected value of ax plus b equals a times the expected value of x plus the constant b. Or we can write it as the mu of ax plus b equals a times mu of x plus b. Let's apply this formula with this example. We have gone through this example in the previous video. The following table gives the probability that X photocopiers are sold in a week according to the past record. And here we have the PMF. Compute the expected unit of photocopier that will be sold in a week. So we have done this before, and we get the expected value of X equals 2.15 units. Let's take a look at a follow-up question. Suppose Y is the weekly profit from selling the photocopiers. If the weekly basic expenses is $3,500, the cost of each sold photocopy is $1,000, and the selling price is $5,340 each. What is the expected weekly profit? So that is, we want to find the expected value of the random variable y, the weekly profit. We need the profit function. Profit equals to revenue minus cost. So here we have the revenue. If we can sell X photocopiers in a week, and the unit selling price is $5,340 each, then the revenue is 5,340 times X, and then minus the cost. The cost is 1,000 times X plus 3,500. For each photocopier sold, the cost is $1,000. And if we can sell X photocopiers, the cost is 1,000 times X, and then plus the basic expenses, 3,500. Upon simplification, we get the profit function y equals 4,340 times X minus 3,500. And we want to get the expected value. The expected value of y equals the expected value of 4,340x minus 3,500. Applying this formula, the expected value of a linear function ax plus b equals a times e of x plus b. And now we have a equals 4,340. And the value of b equals minus 3,500. So what is the expected value of x? The expected value of x is computed as 2.15. So we make the substitution, and then we get the expected value of y equals $5,831. This is the expected weekly profit. All right, so now let's take a look at a shortcut formula for computing the variance of a random variable. The shortcut formula is v of x equals e of x squared minus the square of e of x. Or we can write it as sigma square x equals e of x squared minus mu x squared. How do we get this shortcut formula? Let's start with the definition. By definition, v of x equals the summation of the square of x minus e of x times p of x. Expand the square term, we get x squared minus 2x times ex plus the square of ex times p of x. Expand it, we get three terms. The summation of x squared times px minus the summation of 2x times ex times px plus the summation of the square of ex times px. And then next, we factor out all the constant in the expression. In the second term, e of x is a constant. Together with the 2, we factor that out. We get 2 times ex, and then times the summation of x times px. And in the last term, we get the square of the expected value of x, which is a constant as well. So we factor this out. We get the square of e of x times the summation of p of x. So what is the first term? The first term is the summation of x squared times px. And then the second term, we have the summation of x times px. And then the last term, we get the summation of px. So the second term, the summation of x times px is e of x. And the last term, the summation of px is 1. And the first term, the summation of x squared times px is the expected value of x squared. You can verify this by the formula e of h of x, and here h of x equals to x squared. So the summation of x squared times px equals to the expected value of x squared. So we get the first term as the expected value of x squared. And then the second term, we get minus 2 times e of x squared. And then the last term, we get e of x squared as well. So combining the last two terms, we get the expected value of x squared minus the square of the expected value of x. And this is the shortcut formula for computing the variance. Let's use the shortcut formula to compute the variance of x with this PMF. Okay, we get the shortcut formula. Compute the expected value of x. We need this in the last term. So upon calculation, we get e of x equals 2.5. And then what we need to get the value of the expected value of x squared. So the corresponding expression is minus 1 squared times 0.25 plus 2 squared times 0.1 plus 3 squared times 0.35 plus 5 squared times 0.3. For each possible values of x, we take the square and then multiply by the associated probability. Upon calculation, we get the expected value of x squared is 11.3. And then apply the shortcut formula. The variance of x equals 11.3 minus the square of 2.5, which is 5.05. We can regard the variance as an expected value of a function. Okay, recall the definition of the variance. The summation of the square of x minus EF times P of x. Or we can write it as this. The summation of the square of x minus mu times P of x. Let h of x equals x minus mu squared and apply the definition of e of h of x. So here we have h of x equals the square of x minus mu. And then we have the variance formula. The variance formula can be expressed as the expected value of x minus mu squared. That's it for today's video. Thank you for watching. In the next video, we will talk about variance of functions of a discrete random variable.